I'm going to start today by doing just a brief introduction. Some of you may have seen this before. It's talking about some of the points of why would like to select Lord Inertial as your inertial provider for all our products. I'm going to go over some of the expertise that we have here and some of the proprietary information that we use here to design our devices. This first slide is showing a comparison between temperature compensation for a gyroscope. It's the same gyroscope used by a competitor, and we tested it to see how good the temperature compensation was. You can see in the top graph the temperature is going up and down, and the competitors the temperature compensation is not as good. We've been doing it for years. We have our own proprietary in-house calibration. We're on our third generation of calibration equipment, and we're actually designing a fourth generation. The other thing we do here is we're able to test a lot of the MEMS sensors that are available out there, and they vary a great deal in their performance. They may even have similar specs, but when you actually put them in a dynamic type of environment, they behave differently. This graph on the top shows a device that we tested because of the promising specifications, but then it turned out that as you move up and down in temperature, the bias did not stay stable. The device we actually selected in the end is the bottom graph, and you can see how the gyro bias is stable throughout the temperature range. We concentrate on miniaturization. I think we can reasonably claim that we're the smallest and lightest in our class of sensors, and that's all three classes that we are covering right now, including our tactical grade device, the device you see on the bottom, the CV5, which you see in the top left, and the GX5, which you see on the top right. As I mentioned, we focus on miniaturization, calibration. We also have a new Kalman filter, which is using auto-adaptive technology, which makes the accuracy under dynamic conditions a lot higher. I'll show you a graph in a minute what that means. And then also we have the MIP Applications Programming Interface, which we introduced with the GX3 years ago. And we've maintained the consistency of the API so that it's easy for customers to move from device to device, either up and down the product line or across the product line without doing any additional engineering. And of course, Lord is a global corporation. We have offices all over the world. We have sales support over the world. And we pride ourselves in collaborating with customers to give them solutions that best match their application. So today we're introducing the CV5. We're introducing the IMU, the vertical reference, and the attitude heading and reference system, 3 devices. The main focus of this device was to provide a lower cost OEM style device. If you're familiar with our 3DM GX3 OEM, that was a very popular device. We waited a long time to replace that with something better, and what we've come along with is actually quite exciting. Its performance is really good. Its price is really good, and it meets all our criteria for the quality of the MEMS that we use. As I mentioned, there's the 3 models, the IMU, the vertical reference, and the AHARS. The IMU is strictly an IMU. It's the first time we've introduced an actual IMU that has no calculated outputs. It's just a pure gyro and Excel. We've been asked about this for a long time because a lot of people just need an IMU, and they're not interested in the added cost for the circuitry that we have for the VR or the AHARS. So the CV510, you'll see that the pricing on it is pretty attractive. The same is true for the 15 and the 25, but it's a new model in our model line. We'll be introducing that in some of our other product lines also in the future. So the 10 will be kind of a standard offering across our product lines. The other thing about the AHARS is that we've introduced auto mag calibration. It's the same as the mag calibration we introduced with the 3DM GX5. It's the same footprint as our GX3 OEM. The only difference is it's a flipped over footprint. With the 3DM GX3 OEM, we found a lot of customers that were just turning it over and mounting it directly on the PC board. It was originally designed to use a ribbon cable, so we decided the customer was right, and we designed this to be mounted directly to a PC board, and you can also mount it on a chassis and attach it with a ribbon cable. You can use it either way. The performance of the CV5, it turns out, is going to be very similar to the GX3 OEM, so we considered it a replacement for the GX3. It isn't the same quality as the GX series, which is a higher performing set of devices, but the performance is similar to the GX3, which a lot of people still like, and it's adequate for a lot of applications. Some more of the key features, again, lightweight and low profile. We focus on keeping it as low profile and lightweight as we possibly can. We found a very good accelerometer, which is one of the missing pieces for low-cost devices. So we're using a very, very good accelerometer for very good performance as far as pitch and roll accuracy. We have the automag calibration, as I mentioned, on the AHRs. All our devices have always been fully calibrated and temperature compensated, and that's no different with the CV5. We do not ship anything that's not calibrated or temperature compensated. We designed this to be an excellent performance for cost-sensitive applications, great price-performance ratio. We also built in some precision mounting features. It's difficult to get precision attitude, the kind of precision that we're looking for, fractions of a degree in accuracy, without having some features that allow you to keep the device in one place. So we've designed the device so that you can add precision alignment pins to your application if you need repeatable precision alignment. The connector is a very simple header connector. The mating connector for your application is very inexpensive, under $1, but very reliable. The housing is a one-piece housing. It's very low-cost housing, but it is CNC aluminum, so it's very precise, very rigid. The feature of all our 5th generation devices is the devices that have the Kalman filter, the vertical reference and the AHRs, which have the Kalman filter. We've added this feature called auto-adaptive. Simply stated, the auto-adaptive feature takes into account the noise of the system that the device is installed in, and it adjusts for it. The importance of that is that it's able to reject linear accelerations that cause inaccuracies, but also still be able to measure gravity accurately. And that type of measurement varies depending on the amount of vibration and extraneous motion in any given application. And it's different over all the applications. I'm showing here a slide of a course that we took in a boat on a lake. There's a lot of linear accelerations, a lot of pounding, a lot of rocking, as you can imagine on a boat. We're going about 40 miles an hour and hard turns. And the graph shows the red line is the roll error compared to two of our competitors. And you can see when there's a lot of linear accelerations that it can cause errors unless you have some sort of adaptive technology. And our auto-adaptive technology really dials in the accuracy and makes it suitable actually in a lot of applications that typically use a GPS INS. I'm going to show you in this next slide a little animation, the boat moving around the course. Each tight turn, there are lots of linear accelerations, and you can see it in the blue line, but ours stay stable. The automag calibration, this has been one of the most difficult things for customers to deal with in their application, is how to calibrate the magnetometer accurately. We've always had the external tool, but customers often have a hard time attaching an external tool like a laptop in an application in order to calibrate the magnetometer. So we have a built-in feature that you can turn on, you can either enable or disable, and it will continuously calibrate the magnetometer until either you are satisfied with the accuracy and you can capture it at that point and then turn off the auto mag cal, and then you'll just have a captured calibration. Or you can leave it on and it will continuously calibrate while you're running. This next slide will show a video of how this actually operates in a marine environment. Of course, this is a sped up video, but going over the course, you'll see that the red line is the heading error. So the error is driven towards zero on the heading just by detecting the physical motion of the boat and taking that into account by looking at the magnetometer and comparing the two and adjusting the magnetometer to match what it's reading on the gyros and the accels. And there's even more features. All the 5th generation devices use the same technology. So it's using the same technology as our GX5, the auto-adaptive and the auto-magcal. The first letter of the model name, the C, as in CV5, indicates the packaging. So this package is a C package, and devices that we introduce later, if it has a C prefix, that's this type of package. It's the OEM package. The G packages are our general purpose industrial packages like the GX5, the GQ4. The API, of course, is cross-compatible across all our devices. The interface is a TTL UART up to a megabaud. It's the same interface that we had on our GX3 OEM. It's one that we've had for years, and people like it, so we keep it. The vertical reference and the AHRS have both the UART and USB communications, so each device has both communications channels available to them. The user can use one or the other, but not both at the same time. And power is standard 5 volts DC.